Number 17 is on the Strecker synthesis of amino acids. Now I will admit I'm not too familiar with this because this is actually my first time seeing it. I had to look it up on Google to kind of get the reaction mechanism down, but I think I understand it now. But if I say anything that contradicts what goes on in lecture, go with what the professor says over what I say. Now, based on what I'm seeing is, first of all, let's identify a key point of every amino acid you ever deal with. Every amino acid you will ever deal with will have two carbons in it. One carbon will have a carboxylic acid on it, the other will have an NH2 group on it. And then whatever the other thing that comes off that carbon will be your R group that changes the type of the amino acid. The amino acid we're looking at in this question is leucine. And what differentiates leucine from other amino acids is an isopropyl group, 1, 2, 3, 4 carbons. Now the way the Strecker synthesis works is you start from an aldehyde. And that aldehyde right here will be the carbon that the R group is coming off of. So in this case, the aldehyde that you would be working with is a carbon with 1, 2, 3, 4 carbons coming off of it. 1, 2, 3, and 4. And that is already, so the question was asking which of these structures is not part of the Strecker synthesis. And so it's basically asking you what is the mechanism and what are the intermediates. And so this right off the bat would be your starting material, and that is choice 5. So right off the bat we have one part of the answer. Now let's look at the next step of the synthesis. What happens next is a Cn minus will come in. Oh, sorry, skipping ahead. A NH4 plus comes in, which is ammonia, an acid. Now I should probably write what usually goes over the arrow. Usually over the arrow for a Strecker synthesis, you will see KCN, so a source of Cn minus, and then NH4 positive. There's some weird stuff you don't usually see on the arrow, so you know it's this reaction whenever you're dealing with it. Now what NH4 plus will do is it's going to give you a hydrogen that will protonate the carbonyl. So that oxygen will grab the proton and neutralize the nitrogen. And now you would have a double bond OH positive with that hydrogen. Now what happens is that NH3 that you have left over, that NH3 neutral that you made when you grabbed that proton, will come in and attack that carbonyl, and this will swing up to the oxygen. So right now we're just going through an imine mechanism, meaning a nitrogen attacks a carbonyl, and you end up kicking out that oxygen from the carbonyl as water, creating a carbon-nitrogen double bond. So now I have OH neutral, the hydrogen that was there, and the NH3 positive. Okay, and I'm going to draw out one of those hydrogens because your next step is going to be a proton transfer. This oxygen is going to grab one of those protons and neutralize the nitrogen. So grab that proton, nitrogen is now neutral, and we have this as our next intermediate. A OH2 positive, the hydrogen, and then NH neutral. Now the next step, like I said, this is an imine reaction, meaning you're going to form a carbon-nitrogen double bond. And for that to happen, okay, so this is NH2, okay. So now that nitrogen is neutral, and now this nitrogen will swing down and kick out the water. And as a result of that, you will get the carbon-nitrogen double bond NH2 positive. And so this is the second intermediate or the first intermediate you tend to get in the Strecker synthesis. This is basically the halfway point. Now, if we look at our answer choices, this is also one of the possible choices. This is choice 1. Now the next step is you have NH2 positive, and you want to have something attack this carbon over here. Whenever you deal with carbon-nitrogen double bond, you can picture it the same way you picture carbon-oxygen double bond. Things tend to attack the carbon of that double bond and push electrons up to the oxygen, or in this case, the nitrogen. So remember, the other thing in our arrow is KCN, a source of Cn minus. So this is where the next step comes in. That Cn minus is going to attack that carbonyl and the electrons are going to swing up to the nitrogen. And so now you will have a single bond NH2 and a C triple bond N attached there. And this is also a possible choice on the list of structures. This was choice 3. So far we have 5, 1, 3. Now, the structure synthesis isn't done because this is supposed to end with an amino acid, but this is as far as all the answer choices allot you. I will go through the last step just real quick to point out what happens. The last step involves some H3O positive. And if you remember what H3O positive does in the context of C triple bond N, this was something you learned for the second exam, it ends up adding a bunch of oxygens to this carbon, kicking that nitrogen out as NH4 positive, and then you end up getting, NH3, and then you end up getting a carboxylic acid there. So what you would have at the end of the Strecker synthesis, NH2, and now this carbon, which was the carbon of the C triple bond N, is now has a double bond O and an OH, a carboxylic acid. And that's where you get the 1,2 carbons that are privy to every carboxylic acid, one with a carboxyl, this is where you get the 2 carbons that you always find in your amino acid. One that has the NH2 and one that has the carboxylic acid, and then the R group, which we said was for leucine. So the answer to this question was choice E, which said structures 1, 3, and 5 were part of the Strecker synthesis. Again, this is something I'm new to, and I don't know if there are any secret rules behind it, but this is the way the mechanism will look.